In the last video, excuse me, we derived the product rule, all right? And recall what the product rule says. It says that if you want to take the derivative of the product of two functions, okay, then basically make two copies of this product. In the first copy, take the derivative of the first function. In the second copy, take the derivative of the second function, then add them up. Let's use the product rule to take some derivatives now, do some examples, okay? Just to check that what we're doing is correct, let's take the derivative of this product, first of all, without using the product rule. Well, if we look at this, this would be the derivative with respect to x of, when I multiply things together, I'll have 3x to the third plus 5x squared minus 12x, then minus 20. And so remember our rules of differentiation. We can go through, take derivatives term by term, and take out constant factors. So I'd have 3 times the derivative with respect to x of x to the third plus 5 times the derivative with respect to x of x squared minus 12 times the derivative with respect to x of x, which we could also think of as x to the first, minus 20 times the derivative with respect to x of 1, which is x to the 0 power. Using the product rule, this would be 3 times 3x squared plus 5 times 2x minus 12 times 1 times x to the 0 minus 20 times 0 times x to the negative first. And of course, this would be 9x squared plus 10x minus 12 minus 0. So this would be the derivative. All right, maybe we'll make a copy of that to keep in mind. And next, let's take the same derivative, but using the product rule. Let me just paste it up here so we remember this. I'll paste it, I guess, down here. So we remember this was that derivative, the derivative of (3x plus 5 times x squared minus 4 was this. Now let's do this using the product rule. The derivative with respect to x of 3x plus 5 times x squared minus 4 is equal to, remember that we have the product of two things, so make two copies. So we have 3x plus 5 times x squared minus 4, and then another copy. All right. In the first copy, we'll take the derivative of the first factor. In the second copy, we'll take the derivative of the second factor, and then add those together. All right. Well, I'm not going into as much detail, but when I take the derivative of 3x to the first, I just get 3. And when I take the derivative of 5, it's a constant, so I get 0. So I have 3 times x squared minus 4 plus 3x plus 5 times, well, when I take the derivative of x squared, I get 2x minus the derivative of 4 is 0. So I simply get this expression. Let's multiply these out and see that we have the same thing. So we'll have 3x squared, remember to distribute, minus 12x, and then remember to distribute when we multiply these. So I have 6x squared plus 10x. I'm sorry, this would have just been 12. My mistake here. 3 times 4, negative 4 is 12. And so this will be 6x squared and 3x squared is 9x squared plus 10x minus 12. Notice the very same results we had from above. Let's take a look at another example. All right. Let's suppose, all right, that h of x is 2x to the third times g of x, and that at 2, when x is equal to 2, g of x is 5 and g prime of x is 7. What we want to do is find h prime evaluated at 2. So first of all, h prime of x, well, since we have a product, make 2 copies. In the first copy, we'll take the derivative of the first factor. In the second copy, we'll take the derivative of the second factor. And this is going to be 6x squared times g of x plus 2x to the third times g prime of x. This will be h prime of x. All right, then h prime of 2 is going to be h prime of x, where each instance of x has been replaced by 2. So that will be 6 times 2 squared times g of 2 plus 2 times 2 to the third times g prime of 2. Okay? Well, this will be 6 times 4 is 24, times g of 2 is 5, plus 2 times 8 is 16, all right, times g prime of 2, which is 7. And so, let's see. So when I multiply 24 times 5, I get 120. When I multiply 16 times 7, I get 70 plus 42 is 112. And when I add these up, I get 232.